Alright, guys, so we want to do part 2 of lesson 6.4. And last time we said basically the best type of sample you can take is a random sample. And then we said the most basic random sample you can take is a simple random sample. And we said that a simple random sample gives every individual or group of individuals an equal chance of being selected. Okay, so there's no bias in a random sample or a simple random sample. And then there's a little box here that shows you how to take a simple random sample on your calculator. I might do a tutorial for you about this, a separate tutorial to show you how to do this, but it's not very complicated. Follow the steps and you should be fine. Just remember like a command like rand int 1, 310. 1 is the smallest number and 300 is the biggest number, and 10 says give me 10 numbers in the range 1 to 300 inclusive. So from 1 to 300, okay? And then if you do this on your calculator, hit math, go to prob and select rand int, and you enter a command like this, then you'll get a long list of numbers here that gives you some random integers, okay? So you can see if you use this command, sometimes you can have repeats. And if that happens, you just do it again, and it'll give you a new list of numbers that you can then pick one of the other numbers. Oh, actually, the number 8 was repeated 3 times. Wow. Okay. Also, you can use randint no rep, and that will not repeat. Will not have any repeats, depending how old your calculator is. Sometimes randint no rep means something else, right? But for the most part, that should work. And if you get repeats, just do the command again, and it will generate another list of random numbers. And you just pick, just cross these off, and then just pick the next one that comes up. Okay, something like that. So I think I might make a separate tutorial for you about that. But what we want to do is say, okay, now that I know how to find random numbers on my calculator, how do I use random numbers on my calculator to take a random sample? Okay, so I'm going to go over that with you right now. It says you are a member of the prom committee. You want to poll members of the senior class to find out where they want to hold a prom. There are 324 students in the senior class. Describe a method for selecting a random sample of 40 seniors from the poll. This is actually very similar to what we do in AP Statistics for our final project. Something like this. Seems very simple, but there's a lot of math that actually goes into it. So what you want to do here is say, devise a system, a set of steps for you to take a random sample. So how this should work is if I read your steps, I should be able to take a sample and do precisely what you would do if you take the sample. So it's like a recipe you give to someone that they can follow, right? So I'd say step number 1 is make an alphabetical list of all 324 students in the senior class. Okay, so I've got my list of names, right? Probably an Excel spreadsheet, and then what you would say, number 2 is number the students from 1 to 324. So each student has a number associated with their name, right next to their name. Again, Excel does this very well. And then the third step you would do is, on your calculator, generate 40 random numbers that represent 40 seniors. All right, so you do this. Generate 40 random numbers, and on our calculator we will use rand int, then something like, and rand int is fine, and then something like 1. So 1 is the smallest number right here, up to 324, and don't close the parenthesis, and I want 40 of them. Okay. And then you have to say something like, you skip any duplicates or repeats. So you might have to run the command again, because it's likely out of 40 numbers, like happened here, some number might get repeated. So you just skip duplicates and make another, generate some more random numbers if that happens. Okay, or you can use rand no rep if your calculator has that function. And then 4, choose the 40 students who correspond to the 40 random numbers. Okay, so this is a strategy that anybody can follow using your calculator and come up with 40 random numbers that will be useful for selecting 40 students randomly. Okay, the next thing is kind of similar, example 5. So I actually it's almost exactly the same thing, except you would just change the numbers from 1 to 300 and you're sampling 50. So I'm not going to rewrite this whole thing. You can try it and practice it if you want. The completed note sheet is on Schoology if you want to check it, but it's pretty much the same thing. Okay, it's just another practice of that same thing. So I'm not going to go over that. Now, so the question is, once I've taken a sample, what do we do with that information? I have a sample of people, but the question is, you want to ask them a question, which is, where do you want to hold the prom? Okay, in this case, it was asking people how long your workday should be and how many days a week you want to work. Okay, and what's the preference? So usually these types of things lead to a proportion or a percentage of people that want to do something. So I have to add a little bit of information here because your textbook kind of just jumps into something that's really out of context. Okay, so usually something like one of these scenarios here, for example 4 or 5, you would ask people a question and you would get from your sample, you would get a proportion, okay, of people. So from your sample you would get a proportion of people who answer a certain way. Okay, answer a certain way. All right, and let's just say in our case we'll call that proportion P. All right, let's just say we'll call it P. In AP Statistics we use a different notation for this. But let's just say we call it P. So, and let's say it's, let's say in this case, let's make up a number. So seniors, let's say we ask the seniors who wants to hold the prom, I don't know, at the Hyatt or something. And then let's say 30% of the students, so 0.3 or 30% of the students say, oh, I want to go to the Hyatt for the prom. All right? And this is a proportion I get from my sample. All right? So the problem is, because I'm looking at a sample to determine how everyone feels, my sample is not exactly the same as the whole group. So I took a sample of 40 seniors and I asked them a question and I got a percentage of them that want to go to the Hyatt for their prom, but that's not all 324. So my proportion that I got here is very likely different from the proportion of all students that want to go to the prom at the Hyatt or something like that. So we have a name for the difference between what actually would be happening with all the students if I could ask all of them, and what's happening in my sample, the students that I did ask. That difference between those two numbers is called a margin of error. Okay, and it's defined as giving a limit on how much the responses of the sample would differ from the responses of the population. So if we think about that picture I had on the note sheet in the beginning, here's my population of 324 seniors, and then from that population I take a sample, and there's only 40 seniors here, okay, 40 seniors, and here's 324 seniors. And from here, I get a proportion, because I can only ask my sample what proportion of them want to go to the Hyatt, and that's 30%. But there is a proportion from the population, okay, but we don't know what that is because we can't ask all 324 people, okay, because we can't necessarily reach them. Now, in this case, maybe we could reach all of them, but in real statistics for huge populations, like the whole of Korea's adults or something, or the whole of Korea's seniors, you can't reach all of them. So there is a true proportion here from the population, and it's very likely different from the proportion we got from the sample. These two things are not the same. How different are they from each other? That's what margin of error describes. Okay? And so they said, for example, if 40% of the people in a poll prefer candidate A, and the margin of error is plus minus 4%, then it's likely that between 36 and 44% of the entire population prefer candidate A. Okay, so in their example here, I went my sample people, okay, gave me a proportion of 40%. And they're saying that the margin, what do they call it there? They don't abbreviate it. I'm going to abbreviate it like this. Margin of error is plus minus 4%. That means the population proportion could be the population proportion could then be 40% plus minus 4%. So, and this is something we call a confidence interval. It could be anywhere from 36% to 44%. Usually in statistics, we actually write it as decimals. Okay, 0.44. And so, so this thing here, margin of error, tells me how far could the population proportion be away from my proportion I got from the sample. And you'll see that the sample proportion is right in the middle. So this stuff, none of this stuff is mentioned in your textbook. You should note that this is called a confidence interval. Okay, that's the name for this kind of a thing, and that's what this whole thing means. So it says you can see here a bit of an inverse relationship between sample size and margin of error. It says here, when conducting a survey, you need to make your size of your sample large enough so that it's representative of the population. Then it says, as the sample size increases, the margin of error decreases. Well, you know that makes sense here. As this number gets bigger, the whole fraction will get smaller, and the margin of error is equals to the whole fraction. Okay, so that makes sense. If I have plus minus 1 over root 4, my sample size is 4, then I would have plus minus 1 over 2, so my margin of error is 0.5. Okay, but if my sample size, so this is a sample size of 4, if my sample size goes up to 16, then I would have my margin of error be plus minus 1 over root 16, which is 1 plus minus 1 over 4, which is 0.25. In this case, my sample size is 16. Okay, so as the sample size gets bigger, the margin of error gets smaller. That's an inverse relationship, which is what we did at the beginning of chapter 5. All right, and so that's what all this says. And so this formula right here is basically the same as what I wrote up here for 40% plus or minus 4%. The 40% is your proportion that actually came from the sample, okay? And it says that the margin of error is 4%. And they express it like this, the proportion plus or minus 1 over root n. Okay? So, that's a lot of information. The math for this is not that hard, except there's one or two homework questions that are quite tricky. But the math that we do in our examples here are not that bad. Okay, most of your work is pretty straightforward. So, example 6 says in a survey, so many people were surveyed. Okay, a survey of 1,535 people. That's my n, which is my sample size. 48% preferred one brand of toothpaste over two others. So this would be my P, my proportion. Okay. What's the margin of error for the survey? What's the margin of error for the survey? So all you have to do here is say, use the formula. Margin of error is plus minus 1 over root 1535. And that's equal to plus minus 0.026. Okay? There's the margin of error. All right? And then it says, give an interval of percentages that's likely to contain the exact percent of all people who preferred that brand of toothpaste. All right, so the survey had a sample of 1535, but now we're talking about the population. This is the population of all people. So we know that the population will be the proportion that came from the sample plus or minus the margin of error. So you have this P plus or minus 1 over root n, which is, in this case, my P is 48% plus minus, and we said 0.026, which is about 2.6%. Okay, and so if you do that math, 48 minus 2.6, you get about 45.4%, and then 48 plus 2.6, you get 50.6%. And so you can write it like this or like this, either of these, but this is preferred because it shows you the exact proportions that the population proportion would be in between. Okay, and actually I have to admit that this is also confusing. In statistics, we've been learning interval notation this whole year in Algebra 2. In statistics, we use open parentheses for a confidence interval, but we mean inclusive. That's very confusing. So we've been taught that in algebra and in calculus, you always write things like this when you mean inclusive. Okay? But in statistics, it's okay to write this for a confidence interval. Right? For a confidence interval. Confusing, but this is how we use it. All right? And then let's do another example real quick. Actually, example 7 is again exactly the same. Example 7 is a repeat. It's exactly the same. So I think, except the two numbers have changed. It's just these two numbers instead of 15, 35, and 48%. So I think that's not necessary for me to do that. I think if you're okay with this, if you're not, you can read the completed note sheet. I don't want to make this video too long, so let's just skip that. Let's do example 8, and then we'll be done with this, all right? And I've already uploaded the day 2 homework on Schoology, which is basically, I think the day 2 homework here was basically this part of the homework assignment. That's already on Schoology for you to see, okay? So, example 8 says a state legislature conducts a poll to determine if the voters want to make highway improvements. How many people were surveyed if their margin of error was 3%? So they're telling you this. This is the margin of error. All right. So, all right, I have a formula for margin of error. The margin of error is plus minus 1 over root n. Okay. So they're asking how many people were surveyed. So they're asking, what is my sample size, n? That's what n means, my sample size, okay? And they're giving you the margin of error. So you say, now please remember, margin of error according to this formula is always a decimal, okay? It says right here expressed as a decimal. And when we calculate it, we got a decimal. But then sometimes we write it as a percent. You can also write this as a decimal if you want, but the textbook likes percentages for this for some reason. So, when you do this, you need to convert your margin of error to a percent, to a decimal, okay, to a decimal, to use it in this formula. So if we use it in the formula, we have, and plus or minus there, plus or minus 0.03. So if I plug this in here, I get, I don't know why I did that, I get plus minus 0.03 is my margin of error. That's equals to plus minus 1 over root n. I want to find n. Well, we've learned how to do this already. You can remove the square root by squaring both sides. So you have some options in what you want to do. I think, for me, easiest thing to do is to square both sides. Okay, and if you do that, now squaring plus minus turns it into a plus. The square of a negative is positive, and the square of a positive is positive. So I just get this number, 0.0009. Okay, and then again, this becomes a plus, so I just have a positive, and then 1 squared is 1 over root n squared cancels the root, so I get this. Alright, and now we learn how to do this also in chapter 5. This is cross multiplication. You just cross multiply, so you get 0.0009n equals to 1. This is just over 1, so 1 times there. Okay, and then divide by 0.0009, divide by 0.009, and so if you punch that in your calculator, you get about 1111 people. Okay, and let me see something here real quick. I wanted to see what that actual number is. 1 divided by 0.0009. You get, okay, so what you get is, actually you get this number. You get 111.11. Actually, in this case, what you should do to make sure everything works correctly, you should choose the bigger sample size. You should always, this is talking about people, okay? I can't sample 0.11 of a person. So actually what you should do is say my sample size that I'm going to use will be 1112. I'll round it up. So always round up for sample size. So that if you pick a bigger sample size, your margin of error will actually be slightly smaller than that. Okay, that's good. I want smaller error. I don't want bigger error. So this is what you do with sample size. When you get a decimal, any decimal after the decimal point, then you just round up to the nearest integer. Okay guys, I hope that was useful. Please let me know if you have any questions.